Now that you've finished section 2.1 and you understand the definition of the derivative and know that the derivative is the slope of the tangent line, you're ready to leave the limit process behind for a little bit and start learning the basic rules that will make finding the derivative much quicker and more efficient. Let's go through a quick list of all of the rules that we're going to cover in this section. We've got the constant rule, the power rule, the combination of these two as the constant multiple rule, the sum rule, the difference rule, and the sine and cosine rules. We're going to go through each one, but make sure that each of these are in your flipbook and in your notes. You need to memorize them. I would write them down on a list every single day. See what you can do from memory. So let's start by talking about the constant rule. This is the easiest of our rules. We're going to look at a function where f of x is equal to 5. So we know that's the horizontal line, y equals 5. So at 5 on my graph, I'm drawing a horizontal line. Remember, if I'm finding the derivative, I'm finding the slope, and the slope of a horizontal line is equal to 0. So the derivative of any constant is equal to 0. Your second rule is your power rule. So let's look at a basic power. F of x equals x squared. The power rule says, drop your exponent in front of your variable and subtract 1 from your exponent. So the derivative, f prime of x squared, is equal to 2x to the first power. One more. If I have f of x is equal to x to the 7, then f prime, drop the 7, subtract 1, 7x to the 6th. You do not have a rule for the following. Anything that's inside a parenthesis carried to a power. You can only use your power rule on single variables to a single power. Don't use it on something like this. There are rules coming for that, but not in this section. Let's talk about the constant multiple rule. And we also want to apply it to the only other rule you know at the moment, which is your power rule. So if I have a function, and in this case I'm going to do it with a power, I want to derive 6x to the third. That 6 can just sit and wait. See how in my rule that constant is just sitting out? The 6 is going to sit, the 3 is going to drop, and then subtract 1 from your exponent. My derivative, f prime, is equal to 18x squared. We can do this all in one step, so let's do another one. G of x is equal to 7x to the 5th. G prime would be 35, 5 times 7, drop 1 from the exponent, x to the 4th. What you do not have a rule for, a constant that is multiplying anything that's complex. You have only a power rule with one variable to a power, and you can have a constant sitting outside. But anything complex like this, you don't have a rule for this yet. Your sum and difference rule make your deriving very simple because they allow you to simply look at something long like a polynomial and treat them as individual functions that you're adding and subtracting together. And so we can just look at them individually, derive each one, and the combination of all the derivatives is our answer. So finding f prime is rather quick. I have for my first term 35x to the 4th, second term 12x to the 3rd, third term 18x squared, next term 6x, my last term -4, and why was it my last? Because this term, that's a constant, it's 0, so it disappears. Your sine and cosine rules are very basic. Sine of x derives to cosine x, and cosine x derives to a negative sine of x. What is most important at this time is what you do not have rules to derive. So your derivative rules are very specific. And so you need to understand that they work only for what they say they work for. And so we're going to look at some that you do not have rules for. If you were given a function and asked to find the derivative of sine 2x, that angle has changed from 1x to the first power. You do not have a rule for that. If you were asked to find the derivative of cosine squared x, that cosine is now complex. It's not cosine to the first power of one angle to the first power. You do not have a rule for that. You also do not have a rule yet for the product of two trig functions. So you can't do this one either. The only thing that you can do is the basic sine of x to cosine x and cosine x to negative sine. So let's do our first example. As we look at this example, we look at it and we say, wait a minute, we weren't given a division rule. We don't have a rule for this. So we have to fix it. So I'm going to separate it, rewrite it, and take 2x squared, put it over my denominator, and break up the numerator. As long as the numerator is adding and subtracting, each of these terms belong to the denominator individually. Now I can simplify, and I can say the x in the first term cancels with one of those. So my first term is now just 2x. I have a rule for that. I can derive that. The next one, the x's cancel, and it becomes negative 3. I have a rule for that, but I don't have a rule for 1 over x. In order to rewrite it so that it looks like a power, I pop it up, make it an unhappy x, so it's x to the negative 1, and that I have a rule for. So h prime is 2. The 3 is 0, and the x to the negative 1, the power drops. The exponent subtracts 1, so negative 1 minus 1 is negative 2. Negative exponents are not allowed in answers, so I'm cleaning up my answer. And h prime 2 minus 1 over x squared. Example 2. They want us to write an equation of the tangent line for y equals 3x 6 minus 5x squared. So I know I need a point and I need a slope. My slope is the derivative, y prime, but I don't have a rule for a product. So I have to rewrite it into something that I do have a rule for. So 3x times 6, 18x. 3x times 5x squared, 15x cubed. Now to derive it, I get y prime is equal to 18 minus 45x squared. Now I want to know when x is 1, what is the slope? So my slope, m, is going to be equal to 18 minus 45 times 1 squared. And 1 squared is 1. So 18 minus 45 is negative 27. So now the only other thing I need is a point. So I take the 1 and I plug it in, and I have y is equal to 18 times 1 minus 15 times 1 cubed. So I have y is equal to 18 minus 15, or in other words, 3. So y minus 3 is equal to negative 27, x minus 1. Y is equal to negative 27x plus 27 plus 3. And my final tangent line, y is equal to negative 27x plus 30. Okay, so now let's do a trig equation. We want to determine the points, if any, where the graph has a horizontal tangent line, but they only want us to do one rotation of the unit circle. So I want to derive my function f prime becomes that square root of 3 is a constant multiplying my x, and so square root of 3, 1x, the 1 would drop, multiply the square root of 3, x to the 1 minus 1 is x to the 0, so it's just square root 3, plus the cosine derives to a negative sign, so I get a negative 2 sine of x. And so now I want to talk about having a horizontal tangent line. The slope of a horizontal tangent is 0, so I take my slope and I say, where is this 0? So I set it equal to 0 and solve it. So sine of x is equal to subtract root 3, divide by negative 2, it becomes a positive. Where is sine positive root 3 over 2? It's at the top where we have pi over 3. You have a coordinate that's 1/2 root 3 over 2. And it's symmetrically across the y-axis, also at the top at 2 pi over 3, where you have a coordinate that is negative 1/2 root 3 over 2. And so our answers, pi over 3, 2 pi over 3. Our example number 4 is going to be a position equation for a stone that's tossed vertically into the air from the ground level with an initial velocity of 15 meters per second. So part A, they ask us write the position equation for the height of the stone in terms of t. So our position equation S of t is equal to the gravitational constant. For meters, that's negative 4.9. For feet, that would have been negative 16. Multiply that times t squared, then plus initial velocity times t, plus initial position. Okay, so the first thing that we're told is that it was tossed vertically into the air. That means that initial velocity was positive, it's going up. Then it said it came from ground level. So that means initial position was 0. Our initial velocity, v naught, is 15, and it's a positive 15. So filling everything that we know in, S of t is equal to negative 4.9 t squared plus 15 t plus 0, so we don't need to write the 0. Part B, they want us to compute the stone's average velocity over the time interval, 0.5 to 2.5. So when we see the words average velocity, we want to coordinate that with slope of the secant, because average is average rate of change. Okay, so slope of the secant, we would be taking our position equation and taking our last boundary, 2.5, that's our y2, subtracting our y1, and dividing by x2 minus x1. That's slope. So as we plug those values into our equation to get the values of S of 2.5, we find that that's 6.875 minus 6.275 over 2.5 minus 0.5. We love our calculators, and they tell us that it is 0.3 meters per second. Now they want us to determine the stone's instantaneous velocity at 1 second. So instantaneous velocity means instantaneous change, which is slope of the tangent. And we know that slope of the tangent means find the derivative. So taking my equation, I want to find S prime, because S prime of t is equal to velocity instantaneous velocity. And so deriving, I get negative 4.9 times 2, because I'm dropping my exponent, I get negative 9.8 t plus 15t, t to the 1, 1 times 15, 15, and t to the 1, 1 minus 1, 0, t to the 0 is 1. So negative 9.8t plus 15. Then I plug in s prime of 1 is equal to negative 9.8 times 1, negative 9.8, plus 15, and I get 5.2 meters per second. Now for the final example, we want to find k, the constant in our function, so that the given line will be tangent to the graph of the function. So if I'm looking for k, I need to look at all the variables that I'm missing. Notice that f of x is y, and I have k, and I have x. I actually have 3 missing variables. I don't know any of them. So I've got to start looking for some relationships. So the first relationship that I think of is that my derivative is my slope of my tangent. So f prime of x, which I know is the k derives as a 0 because it's a constant, then negative x squared derives as negative 2x to the first power, and that derivative is equal to the slope of my tangent, which is negative 4. So I have negative 2x is equal to negative 4, and x is equal to positive 2. So I found one variable. Now I can use it to find some of the others. Okay, so I also need to know y so that I can find k. Well, I have this relationship in the tangent line, because remember, the tangent line shares the exact point on the graph where it's tangent to, so that x and y are the same. So I have y is equal to negative 4, plug in my 2 for x, plus 7. So y is equal to negative 8 plus 7, which is negative 1. So my coordinate 2, negative 1 is going to help me find k. So plugging it into my original function, I have negative 1 is equal to k minus 2 squared. 2 squared is 4. If I add it to the other side, I get 3 is equal to k. So putting it back into my function so that I can see the entire thing, I have f of x is equal to 3 minus x squared, because k was equal to 3. Okay, so now it's your turn. Every single one of these you actually do have rules for, but you may have to rewrite them so that you can use your power rule or your constant rule, whichever. So just make sure that you don't break any of the rules and have fun deriving. Your homework is going to span over the weekend, so you have 3 days to work on it. That'll be plenty of time, and you're going to enjoy it. This is where it starts to get fun. Talk to you tomorrow.